Welcome to the DNA Talks podcast, where we take on the mission of unlocking the code of your genetics. This season is all about you, upgrading your health not just on the surface, but down to the root cause. Join us as your clinicians at the DNA company investigate your DNA and beyond. The intention of this podcast is to enhance your lifestyle by changing what is in your control. This does not substitute the medical advice given by your personal doctor, therapist, and other healthcare professionals.
Hello, everyone, and thank you for being here. We are so happy to have you learn more about mitochondrial health in women. We're going to be covering hormonal influences and more. My name is Dr. Lara Varden. I am Dean of the DNA University, and I am one of the in-house clinicians here at the DNA company. And I have, again, the absolute pleasure to have one of our esteemed and brilliant and very much beloved Justin Harris. Hi, how are you doing today?
Hey, Dr. Laura. Good to see everybody again on here. What a topic. I think that we've covered mitochondrial health a couple times between the two of us, and it's forever relevant, right? It matters for everybody. And I think that for women in particular, women typically have this additional toxic burden, I think, on their bodies, like due to the hormonal capacities. And not to say men don't, but women, there's a lot more general toxicity when it comes to things like estrogen metabolites and what have you. So we've got this balancing act, like mitochondria giving you energy. We've got hormones and different things that might be working for or against you. And here we are with this energy crisis for everybody. So tonight we should hopefully be able to dive into some of those nuances to how the hormones and these various things will impact you on the mitochondrial level, and then of course what to do about it, like we do.
Absolutely. And, it really is something, like you said, we talk about mitochondria a lot, mitochondrial health, aging, and there's a lot of influencers and other, very esteemed people talking about that. But here we're really going to be focusing in on mitochondrial health and women. Women are such a underreported aspect, especially in these types of conversations. And with hormones changing in life cycles, I mean, we have very dramatic changes as we age, going through perimenopause, menopause, postmenopause. What do we do? How does the hormones affect that? All these different factors. Not saying that men don't, but it's much more profound for women, through these particular stages in their life. So speaking about women, hormones, the role of estrogen and mitochondrial function, from things that you have studied and working with the clients that you do and the women that you do, how have you found, or how do you approach some of the issues that they come up with, and your understanding of how estrogen is affecting that mitochondrial function?
So the mitochondria, to me, they represent this storehouse of vitality that we have. And oftentimes patients, they come to me with some sort of ailment that's attacking them, and they're kind of trying to deal with some kind of health crisis, whatever's going on with them. And I've always said it takes energy to have an immune system. It takes energy to fight things off. It takes energy to care. It takes energy to love. It takes energy to do a lot of these things. So the health of your mitochondria represent what's left, the life that's truly left in your body to go ahead and combat any of these things that are, plaguing you. So think about it like that. It's a vital reserve that exists within your body to help you to do all these different things, fight inflammation, etc. So there's this thing that I always talk about being homeostasis in the body. And I think that the more working against you, the more likely it is that you are going to come out of homeostasis and have less energy and less mitochondrial efficiency as well. So we look at all these little things, these markers within the DNA to tell you what's going badly at a cellular level. And when we look at the hormone perspective, that can happen with these dominant profiles that have excess, let's say, 4-hydroxyestrogen or excess 16-alpha hydroxyestrogen. It's going to kick the body out of homeostasis because it's one of many stressors. So it's a cumulative toxin load and a cumulative stressor load. And I just go into the genes like I would do, and I kind of pick apart what isn't working for us and then add in the interventions. I know you deal with a lot of patients as well that have kind of a similar concept. Do you do something similar to that?
Oh, absolutely. And actually, I would love to have you speak into that a little bit more in just a moment. But what I wanted to do for the audience sake is give them some information about estrogen itself, progesterone, testosterone, because we as women, we have all of them. Actually, we as humans have all of those hormones, just at varying percentages and levels. But what I wanted to tell all of you is that when we talk about estrogen and mitochondrial function, estrogen stimulates the production of new mitochondria in a process called mitochondrial biogenesis. Now, this is mediated by the activation of specific transcription factors like PGC1 alpha. And I know that's, a lot of scientific information, but, for those of you out there who want to know specifically, the connection of what's going on. But the PGC1 alpha, that actually helps to promote the formation of more energy producing units in the cell. And of course, your mitochondria. So really, estrogen enhances the efficiency of the electron transport chain, which is very crucial for ATP production. It also improves the utilization of oxygen and nutrients, which helps to increase the production of ATP, that energy currency of the cell. And there are certain enzymes that are activated, like ATP synthase, cytochrome C oxidase. These are critical for energy generation in the mitochondria. And estrogen also has antioxidant properties. This helps to reduce the production of those reactive oxygen species, which I know, Justin, you're going to be mentioning when you talk about some of those genes. These are the ROS, reactive oxygen species, are byproducts of mitochondrial energy production. It's kind of like when we go to the grocery store, we buy food, or we buy, the things that we need, we bring it into the home. So that's food, nutrients, we bring it into the cell. Then we do the work, we eat the food. Well, we end up with some trash. That trash needs to be taken out. So this is the same type of thing. For that mitochondrial working, it creates these waste byproducts, and that needs to be removed. Well, estrogen helps to do this. So it helps by lowering the oxidative stress when it's removing and getting rid of these reactive oxygen species. So estrogen helps to maintain mitochondrial integrity and efficiency and protects the cell from damage that could impair energy production. So very briefly, though, I do want to touch on progesterone and testosterone. So progesterone, this plays a role in mitochondrial function. It's a little different than estrogen, but basically it can enhance mitochondrial activity by increasing the mitochondrial's membrane potential. This is vital for maintaining that energy producing process within the mitochondria. So progesterone's effects are particularly significant in tissues with high energy demands, your brain, your reproductive organs. So this is really important. And finally, testosterone, our next, biggest hormone. Testosterone is known to increase mitochondrial efficiency and ATP production, particularly in muscle tissues. It enhances the activity of enzymes involved in oxidative phosphorylation, and therefore contributing to greater energy output in cells that rely heavily on ATP for function, like the muscle cells. So working into those particular hormones, Justin, could you give some insight on the genes that are related to those hormones and how that looks? Can you unpack that?
Absolutely. There's a few moving parts, as I like to say, about how that kind of goes. There's a really particular family of genes. It's actually a family of enzymes that are encoded by the same family of genes called CYP, CYP. So if you've had your DNA 360 done, you're going to see a whole bunch of these. It's a cytochrome C, what is it, P450 or something? One of
Yes.
those. Yes. And it's a whole family, right? And it has a lot to do with hormone synthesis, particularly on the steroidogenesis pathway. So we have this whole family of them that are determining your progesterone to testosterone conversion, right? That's the first gene in the pathway. It's called CYP17A1. And for some people, that happens at an accelerated rate. So you get a lot of testosterone off the baseline progesterone. For other people, it happens at a little bit slower of a rate, depending on the speed of the enzyme. So that's going to tell us if you have a lot of sex hormones in the first place or if not. If not, you're not going to have as exaggerated symptoms or manifestations of those sex hormones. You're probably going to have a little bit more of a what you might call ectomorphic body type, as opposed to an endomorphic or a mesomorphic body type, which you get from having more hormones at a baseline. So CYP17A1 does that. We look at testosterone into estrogen as well. So the CYP family of genes also does that conversion, because your testosterone can actually androgenize, which means it turns to a super potent form, or it can aromatize, which means it kind of steers more towards estrogen. So this is going to tell you if you have an estrogen dominance in your body or an androgen dominance, or you can have kind of a mixed bag as well. Then from there, we look at those metabolites that I already mentioned. So there is protective estrogen metabolites, and there's ones that are a little bit more toxic or inflammatory. That's also encoded by this CYP, cytochrome P450 family of genes. So 2-hydroxyestrogen is one that you actually wouldn't mind having a little bit of elevation with, because it does have some protective properties on the body. But 16-alpha hydroxy as well as 4-hydroxyestrogen tend to be a little bit more contributor to the inflammation in the body. They're a little bit more toxic. So we want to know how these enzyme pathways go. There's another pathway in the body that we look at called glucuronidation, which is the UGT family of genes. And they actually are associated with the clearance of mainly androgens, but a little bit of estrogens in there as well. So we look at dominance, we look at clearance, and we also look at metabolites to give you a pretty good full picture in your hormone profile.
Fantastic. And you had mentioned glucuronidation, which is one of the phase 2 detoxification pathways. There are a few others that we look at that are very important, so the genes that Justin is talking about, you'll find in your hormone reports. And there are the other phase 2 detoxification pathways that you will find in your anti-inflammation reports. Do you want to mention what those are? Because they're very important, because they are ultimately downstream for the clearance of these other hormonal metabolites, along with many other toxins in the body.
Yeah, and it's important because of that cumulative effect that I mentioned earlier, right? Like estrogen toxicity is one way that the body can have toxins. But we know that, like you mentioned, reactive oxygen species, those are also toxins. If your methylation cycle isn't proper, you're going to get less, anti-toxic load that way. So we look at glutathionization, which we look at 3 different places. We look at liver, we look at gut, and we look at respiratory system. Then we look at the antioxidative effects from the SOD2 pathway. So SOD2 and glutathione peroxidase, GPX, those are what actually clear the toxins at the level of the mitochondria. So probably the most relevant one to this particular conversation tonight. And we've talked about that before, how to clear it, how to help it. Sauna and hydrogen water and possibly peptides, different things that you can do to increase that clearance. But always remember to zoom out. It's the totality of the load. Maybe you have suboptimal SOD2 pathway and a genetic predisposition to have more toxic estrogen metabolites. Well, now we know there's going to be a direct connection there. And those are 2 of your main areas that your body is accumulating a toxic load. So we work backwards from there. Your vitamin D panel matters for how your body detoxifies, how your body deals with inflammation. Your thyroid needs vitamin D. That's a main, metabolic pathway. So it goes on and on when you actually look at it. But look at that glutathionization, and you can bounce these things off of your hormone profile as well.
Thank you for that. And I'm sure people are digging into their DNA 360 reports. And if you haven't gotten a DNA 360 report yet, you can always go to our website, you can contact client care, because this is really foundational information to really know your DNA blueprint. Before we start getting into some of the actionable items, is to talk about some of these hormonal changes and how that's related to mitochondrial efficiency. So, like I had said earlier, these stages in a woman's life, as we are entering perimenopause and menopause, and I will be, forthright, I've actually gone through menopause. So, I've experienced all that and know this intimately, that estrogen and progesterone levels decline. They can tank. That can lead to very notable changes in mitochondrial function and energy production. When we're talking about some of the things, like I had mentioned before, about estrogen being really good for mitochondrial biogenesis, that production of mitochondria. This is where it can decline in estrogen and then obviously making fewer mitochondria being formed. So from this, it can also impair the ATP production. It can also increase oxidative stress. It can impact muscle and cognitive function. So, all of these things, it's very dramatic. And obviously, a lot of times that is what I find clients coming to us for, is saying, what do I do? How can I handle this? So I'm going to shift this over to you, Justin, that what are some of the things that you offer to help support mitochondrial function during these hormonal changes?
So remember that mitochondria only have the capacity to react to the environmental stimulus that you provide to them. So knowing that as a baseline is really useful. And they're these environmental epigenetic sensors, and they react moment by moment to the light stimulus and the toxin stimulus and different things that you do. So ask yourself, what would you do to make a healthy cell? What signals would you want to give to your body to give it the utmost vitality? While we would want some movement in there, we would want some high quality light. We would want some high quality minerals and nutrients. We would want to get hot. We would want to get cold. We would want it reacting in such a way as to recreate itself and detoxify itself, right? So anything that causes mitochondrial biogenesis, like Dr. Laura mentioned, is going to have a direct anti-aging effect, remembering that they're going to slow down as we age, especially if you have additional estrogen toxicity. So just know that if you're doing things like weight training, you're directly increasing the number of mitochondria in your muscles. If you're actively using your brain, if you're detoxifying with things like sauna, sweating from exercise, you can actually cause additional free radicals to be let go. And then your mitochondria replicate, and they actually are healthier and cleaner than they would have been otherwise. I always just say it's about the environmental stimulus. All hormones really are, to an extent, right? If you don't make enough testosterone, for example, we can extrapolate and go, well, you need to give your body the right signals to do such a thing. You should be doing compound weightlifting and using your hips and getting sun tanning and all these different things in there. So it's up to us to give the right stimulus to the body to replicate and produce more mitochondria. Your brain has a huge density of it. Your muscles have a huge density there as well. So it's going to make you smarter, and it's going to help you move better as you age if you give it the right stimulus.
And I will say that the things that we are mentioning in this webinar, please take it as information, education. Because, although I'm a doctor, that, we are working in a clinical setting, we are not your doctors. We are not your coaches. And so if you want to follow up on any of this, we highly encourage you to speak with your physician, with your doctor, with your coach that you are currently working with. If you are interested in working with anyone on our team or with us as a team, our angels can drop some links that you can reach out, get some information, and see about our programs. But start with your DNA 360. At least get the layout, the blueprint of what it is that you're working with. Everything from there is all epigenetic. It is, really accessing and manipulating the environmental factors inside, outside of us, the food that you're taking in, the lifestyle that you are living, and how that can affect your genes. It affects how your genes are being expressed because, yes, they are able to be manipulated and optimized. And that's exactly what we are touching on tonight with these types of action items that we are pro-offering as education. I wanted to touch on another aspect that can be very helpful, and that would be hormone replacement therapy. Now, for some women, HRT can help restore estrogen levels, potentially improving that mitochondrial function, energy production, reducing the oxidative stress, all the things that we had talked about. So, if you are interested in learning more, speak with your doctor. We do have some hormone specialists on staff, and also, so this is something that we can discuss, if you decide to get into a program. So just realize that there's a lot of different things to be able to manage, work, optimize your health in regards to hormones. When you've gone through the stages, how can you make it better? Yes, do the foundational things, do your nutritional support, do your lifestyle changes, lower your toxic load, do some detox. But sometimes that may not be enough, and maybe hormone replacement, is something that can actually make a difference for you. So,
Can I add to that there, Dr. Laura? Just
oh,
to say,
absolutely, please.
yeah, so if that is something that you're considering doing, knowing your enzyme pathways beforehand can really help you to tailor that approach as well, because different doctors are going to tell you different things, right? They might say, let's put you on a progesterone or a DHEA or whatever it is. But having the baseline understanding of, if we add this intervention, all of these things happen after it. If my body naturally produces progesterone and chooses to do this with it, then if we add it in artificially, the enzyme pathway thereafter is still the same thing, right? So it's still really valuable to do your genes first, to know how your body, remembering that this is an instruction manual, is going to take those hormones and what it's going to do with it.
And if you are curious about hormone replacement therapy, bioidentical hormone replacement therapy, and just the changes in women and in women's health and hormones, we actually have done several podcasts and webinars about just this, where we dive into the different types of hormone replacement. What does this do to your body? How does this work? We've got, I was actually on the panel of other doctors, even a PharmD, that actually dives into that. So I do encourage you to take a look at our past webinars for women's health and our podcast, because that dives a lot deeper than what we're going to be doing here today. So I wanted to change over a little bit and talk more specifically about common signs of mitochondrial dysfunction in women, because sometimes you're thinking, oh, okay, well, yeah, there's fatigue and different things like this, but what actually does that look like? And well, common signs, number one, is what I just said, fatigue. That is the most common sign of mitochondrial dysfunction. And because remember what I had said, that mitochondria are responsible for generating the cellular energy, adenosine triphosphate, ATP. And when mitochondria are not working efficiently, the energy production drops. And of course, that's going to lead to that chronic tiredness. And honestly, you need to have energy to do like everything, everything. So even to heal. So, having energy is, and your mitochondria working and functioning well is foundationally so important. Other signs that you might notice, hormonal imbalances. So because the mitochondria are involved in the production and regulation of hormones, dysfunction in mitochondria can lead to imbalances like thyroid issues, irregular menstrual cycles, and adrenal fatigue. So these are things to watch out for as well. Also, brain fog. cognitive problems, including memory lapses, confusion, difficulty concentrating. Yes, I've been there. So it's like, where you're missing words or you can't think of things. These are signs. It doesn't mean that, oh my gosh, I have Alzheimer's. Don't start self-diagnosing or anything like that or jumping to conclusion. Maybe it's just a matter of your hormones are dysregulated. And then what can you do to help with that? So other things like muscle weakness, pain, because mitochondrial dysfunction impairs muscle function. That leads to weakness, cramps, muscle pain, because muscles, as I said earlier, relies heavily on ATP. And then, of course, there's also, chronic diseases, including those neurodegenerative diseases that I mentioned, like Alzheimer's, even Parkinson's, cardiovascular disease, diabetes, metabolic disorders. All of these conditions often arise as mitochondrial efficiency declines. So immune dysfunction, mood disorders, depression, all kinds of things. Justin, do you want to comment on anything else that you have seen?
Yeah, I think this is a chicken or the egg thing as well with a lot of this, because it's like for example, you just mentioned adrenal fatigue. And it's really hard to diagnose adrenal fatigue versus mitochondrial dysfunction, because when you're talking about symptomology, right, so many of these things are the same thing. It's very easy to point to a thyroid issue versus a gut dysbiosis issue versus an adrenal issue versus a mitochondrial issue, because the way we feel when we say things like brain fog, fatigue, it kind of ends up being the same thing. There's usually some sort of metabolic weak link that we can point to, and that's where the genes do come in. The thing about mitochondria as well is that, like we said, it's almost a part of your microbiome. Like literally, these are bacterial in nature. So I think that when you have things like gut dysbiosis going on, it can tip the overall biosis of the whole body out of whack. And once again, we're not in homeostasis anymore. So it's one of those things, it's chicken or the egg, because it could be adrenal fatigue or it could be mitochondrial dysfunction. It could be both, right? So it's tough to diagnose, but we need to just recognize that the brain needs energy, the body needs energy. Every cell in your body has mitochondria. So therefore, there's an energy requirement to each cell. So we need to have the lifestyle factors in place to give the body as much energy as humanly possible. It could be red light, it can be grounding, it can be breath work, it can be PEMF. A little toolkit is usually a good idea to put together when it comes to how to upregulate and improve mitochondrial health.
Yeah, and it really is nuanced. There's so much to unpack. Like you were saying, it's like chicken or the egg. What is it specifically? What is the contributing factor? What is that antecedent? Looking at the DNA, what are you working with? And then what is your lifestyle? What is ultimately your allostatic load, that accumulation of all the stresses, and what is it that you're looking at? Are you being exposed to certain toxins like endocrine disruptors that are so ubiquitous in our food, like atrazine, paraquat, and the big one, glyphosate? All of these are estrogen mimetics or affect the endocrine system, affect our hormones. So sometimes it can be just a change in the foods that you're eating, the toxic exposures that you have in your environment that can make massive shifts in energy production, in the way that you're feeling. It's what I like to say to my clients. It's like, let's clear the muddy waters. Let's see and figure out what's going on, and this is why we really dive deeper into the questions, finding out where our patients, our clients, where are you right now? What is your life like? Putting all of these puzzle pieces into the picture that is you, so that way we can figure out, from your issue, what do we do from here? Where do we target?
Yeah, it's like there's this concept that I work on about not treating the report, like trying to treat the person, not the report. And so there's this term called clinical correlation, right? Where it's like we can point to the reports and say, here's a void in how your genetics work. But I need to know, like, what is your lifestyle behaviors like? How are you actually pulling that trigger with the way that you approach your day? So clinical correlation is a really big part of what we do as well, because that's what really helps me to treat the person, as opposed to treating the lab work and like, oh, your C-reactive protein is like this. Let's give you this to get the C-reactive protein back to where it should be. The C-reactive protein is off because of some other issue that's going on, some metabolic weak link. Something has kicked you out of homeostasis, right? So we treat the person, we clinical correlate. We say, what's your lifestyle? Like, do you have all the way down to crappy toothpaste, or, you mentioned all these different things that give us endocrine disruptors. So we need to audit everybody's lifestyle to really sometimes figure out the real root of the problem.
Yeah, because I mean, it can even come down to mold exposure, bad light. So, there are so many things, that we have had to, research, become aware of. And with our, the experience of working with so many people, that we see the patterns, we tend to find out, and looking in the research that has been done, finding out, going, hey, something that people wouldn't think of, that like mold, or parasites, or, being or sleeping on a mattress that's off gassing toxins. Okay. You never know where exactly that key is going to be, or, that, larger thing, exposure that's going to make the biggest difference. Of course, then again, it's usually never just one thing. It's that accumulation, but generally there's always a larger factor that can be handled. And that's, work on the low-hanging fruit, the things that you can change. Because I know this can seem very overwhelming. It's like, where do I begin? It's like, there's just so many things. And we're going to talk about in a few minutes, some of the specific things that can be done, along with maybe supplements to look at. It's taking one step at a time, kind of like the old adage of, how do you eat an elephant? One bite at a time. So just make that first step. Just choose one thing and do it. So let's dive a little bit into mitochondrial health and aging. I mean, in the factor of degenerative diseases, because I know this is oftentimes, a hot topic and things that a lot of clients are worried about. I'm sure you have found the same thing. And I want people to be aware that there is a difference between cellular DNA and mitochondrial DNA. Yes, we actually have two types of DNA, and our mitochondrial DNA is actually passed down by our maternal line, our mothers. Okay. And over time, mitochondrial DNA accumulates damage due to oxidative stress, resulting in impaired mitochondrial function. Now, this decline leads to lower energy production, increased production of those ROSs that we talked about, reactive oxygen species, and reduced mitochondrial biogenesis. And you're hearing things over and over again because this is the basis. Now, when mitochondria becomes less efficient with age, cells lose that capacity to meet the energy demands. That contributes to degenerative diseases. And I've already mentioned, a few earlier. So when we're talking about mitochondria and longevity, obviously we want healthier mitochondrial function. And, during these hormonal transitions, like I had talked about in perimenopause and menopause, it is very important that we sustain as much of the integrity of our mitochondria as possible. And estrogen, like I had said, plays a very important protective role in that. So doing the things that enhance that energy production, that reduces the oxidative stress. And one of the main things is reducing your toxic exposure. Okay. Now you're already going to have reactive oxygen species from just regular cellular mitochondrial functioning, like I had mentioned, going out to the grocery store, bringing groceries and things in, you're automatically going to have that. But you don't need to overload it more through exogenous toxins, these toxins that you're constantly exposed to. So diving into some actionable strategies on, let's continue to support this. Well, if you could, Justin, I would love to hear some of the nutrition and supplements that you often, will recommend, or that you feel the research has supported for mitochondrial health.
Sure. Yeah, that's one of your main lines of defense, right? What we're taking into our body. Remembering that food, I always say, is information. And what did we say right at the beginning of this? Your mitochondria react to the stimulus that you provide. We could really talk about food as if it's one of those stimulus. So, I'm a big fan of, there's something called the ORAC scale, and they kind of change it every year. And high ORAC foods are high antioxidant foods. And there's some stuff on there that you wouldn't think is on there, like clove apparently is crazy high in antioxidants. Like there's different spices and things that you can add in. But the more high ORAC foods that you use, theoretically, it should help you on that antioxidative pathway. Dr. Laura just said something really important. There's exogenous as well as endogenously created toxins. So something like a 4-hydroxyestrogen or something like a reactive oxygen species, those are examples of endogenously created toxins. You're going to have them anyway. Genetically, we can look at how well of a job you do at clearing those, or how many of them you're likely to make in the first place. But you can have way more toxin intake if you don't eat very good food, right? Glyphosates and all these things, there's added toxins in our diet. If there's toxins in your water and toxins in your diet and toxins in your air and toxins in your skincare products, and now toxins in your estrogen pathway and toxins in your mitochondria just from moving, we need to do some things to help really reinforce these detox pathways. So diet for sure, some blueberries, some walnuts, these things that are high ORAC are great. On the supplement side of things, there's twofold things that we're looking to do. The first one would be the clearance of the free radicals and trying to improve that to the best of our ability. That would be things like molecular hydrogen, right? Upregulating the NRF2 pathway. The other thing that we're trying to do is encourage mitochondrial biogenesis, creating new mitochondria. You can do that via autophagy, things like fasting, not eating at all. You can also utilize things like urolithin A, for example, that we've talked about on this webinar a couple of times, which is an extract of pomegranates that your body turns into urolithin A because it's a postbiotic. So it gets created in the gut thereafter, and you can actually take it in supplement form and get bioavailable urolithin A. Some of these really potent antioxidants like spermidine, resveratrol, I think that they're great to add in to really give your mitochondria a little boost in that toxin clearance. Personally, I'm a fan of carbon-60. I'm not allowed to recommend peptides, but research that one. That's what I'll say. Carbon-60 is a great product because it's like hundreds of times stronger than vitamin C as an antioxidant. And I have a suboptimal SOD2 pathway, and maybe you do too. If you do, we want to get some sort of strategy in place to increase that clearance. You can pair that with something like an infrared sauna, like that beautiful beast behind me there, right? Sweating and then using, nutritive substrates and things to support the pathway. We've got phase 1 and phase 2 detox covered now, and you're going to accelerate this process by a ways. Dr. Varden, what do you do for that?
Oh gosh. Well, honestly, yeah, I always like to start with food. Let's look at what you're eating, what can be shifted in the food that you're eating, because food is information. Food is the basis, that is helping to create the energy in the body through glycolysis, through the Krebs cycle, through the electron chain transport. And so this is very important. But getting to like specific compounds, whether you get it from your food, whether you get it from a supplement, something to note is senolytics. Actually has some great research. And what are senolytics? They are compounds. They selectively target and eliminate senescent cells. These are cells that have stopped dividing but remain metabolically active. And you're thinking, well, metabolically active, isn't that a good thing? Not really, because they're like zombie cells. And they contribute to aging and age-related diseases by releasing harmful inflammatory signals that damage surrounding tissues. They're basically taking up nutrients, but they're not doing anything good for you and actually creating more damage. So by clearing the senescent cells, senolytics actually help reduce inflammation. They improve tissue function, and really they potentially slow down the aging process and promoting healthier aging and reducing that risk of degenerative diseases. So, this is something for both men and women, but definitely, something to look into, because that's really that is the basis of, like what Justin was saying with fasting. We want to create autophagy, mitophagy, that clearance, that breakdown of these old, worn out mitochondrial cells. We don't want zombie cells around. We want them cleared. So that's something, that helps with that. Get rid of the old, in with the new, promote that mitogenesis. Other things, CoQ10. So CoQ10, very critical component of the electron transport chain, and this is where it helps produce ATP. So it also acts as a powerful antioxidant, which obviously that's what we want, because by reducing that oxidative stress, and it also protects mitochondrial membranes, which I had mentioned before. Magnesium. Magnesium is absolutely wonderful. It's involved in over 300 enzymatic reactions, including those related to ATP production. Very important. So it is absolutely essential for the functioning of ATP synthase, that enzyme that generates ATP in the mitochondria. Alpha lipoic acid is also very good, very potent antioxidant that directly scavenges free radicals and regenerates other antioxidants like glutathione, the master antioxidant of the body, and CoQ10. It also plays a role in mitochondrial energy production by supporting enzymes involved in the citric acid cycle. Now, I will put this with a little asterisk in that if you have heavy metal toxicity, especially like mercury, alpha lipoic acid would be contraindicated because that can actually cause some issues. But I don't want to go down that rabbit hole, but I just want to say, if you have mercury, heavy metal poisoning, I would not recommend that. And we actually do have a heavy metal mercury expert on our team. She's absolutely brilliant. So wanted to throw that out there. Also, things like L-carnitine, which is very crucial for transport of fatty acids into the mitochondria, where they end up getting burned for energy. And this helps to optimize mitochondrial fatty acid oxidation. Trying to think. Oh, NAD+. The precursors to NAD+, things like nicotinamide riboside or nicotinamide mononucleotide, these are essential for mitochondrial energy production, and they play a role in DNA repair, which obviously is very important because NAD+, those levels decline with age. So obviously, when that declines, that can contribute to mitochondrial dysfunction and cellular aging. PQQ is another one that helps to stimulate mitochondrial biogenesis. Your B vitamins, we want to support the methylation pathway, but it also is very important because they act as coenzymes in various mitochondrial pathways, including citric acid cycle and electron transport chain, where they assist in that conversion of food into usable energy, like I was mentioning earlier. Vitamin C, E, glutathione, again, major antioxidants, omega-3s, also very, very important, especially EPA and DHA. Because you do want to keep the structural integrity of the mitochondrial membranes and helping to reduce inflammation. There are others. Is there anything in particular, or maybe that may not be as typical that people would know that you want to add in?
Yeah, there's one thing that really stands out actually, and it just jumped into my head now, so I'm glad it did. Melatonin is actually one of your body's primary antioxidants, and it actually directly influences the SOD2 pathway that I mentioned that helps to clear out these free radicals. it's actually really relevant for tonight's conversation because, as you know, when women start to get into these menopausal years, oftentimes their sleep is one of the things that gets messed with and disrupted as you go through the various cycles. So I'm not saying supplement with melatonin, but I do think that it becomes more and more important that you get that high quality sleep and have your melatonin and your cortisol, patterns and rhythms on point there. Because if your melatonin levels start to become suppressed due to menopause, well, now you're actually doubling up on the mitochondrial issues there, because it's actually helping you to clear free radicals at the level of the mitochondria, not to mention all the other good things that happen when you sleep. So if you're going to really place effort into an area to make it better, I would say sleep is one of the main things that you should be focusing on. Natural melatonin rhythms are really, really important for healthy aging, especially when it comes to mitochondria, because if your sleep gets compromised, the cortisol is going to go up. The cortisol is going to compromise your gut microbiome. Your gut microbiome is going to compromise the melatonin even further, as well as the T4 to T3 conversion, on and on from there once we have any kind of dysbiosis. So keep those basics in place. Make sure that your body is nourished. Make sure that your body is hydrated. Make sure your body is sleeping and recovering properly. There's no faster way to be kicked out of homeostasis than to have a bunch of really bad sleeps in a row.
Yeah, brilliant insights, absolutely foundational. Actually, there was a couple things that I also thought of. Resveratrol. That's kind of like a new shiny type thing that's been spoken about in the last few years. And resveratrol actually activates sirtuins. These are proteins that play a role in mitochondrial biogenesis and longevity. Of course, it also acts as an antioxidant. So that's another one. But, something that you had mentioned earlier about exercise, how important that is. And I had mentioned about, muscle and how important estrogen. Well, also testosterone, because getting back to what you were saying about the importance of sleep, testosterone is actually produced while you're sleeping. And ladies, yeah, you want some testosterone that really helps with the energy, with, that motivation, with libido. You want some testosterone. So, along with other things. So sleep, there's another reason why you want good sleep. But getting into muscles, creatine. Creatine helps store and transfer energy within cells, particularly in tissues with high energy demands like muscles and the brain. So, that's something else. And actually, I did want to mention, because it's something that I have spoken about before that I have really been won over, is methylene blue. Now, methylene blue has actually gained attention for its very unique ability to enhance mitochondrial function, especially in the context of energy production and reducing oxidative stress. It's been used for decades in medical settings and is now being researched for potential benefits in mitochondrial health, in the way that it enhances ATP production because it acts as an electron donor within the mitochondrial electron transport chain. It actually bypasses dysfunctional components of that chain and enhances ATP production. So, really incredible. And then, of course, acting as a redox agent, meaning that it can both donate and accept electrons. And this property allows it to neutralize reactive oxygen species and therefore protecting the mitochondria from oxidative damage. So, really the benefits are we are learning more and more in research, and it has been shown to cross the blood-brain barrier and directly support mitochondrial function in neurons. So there's been research done in Parkinson's and other neurodegenerative diseases. So just really incredible. Did you have a comment?
Yeah, I just have one thing. I know we want to get into some Q&A here, but I just wanted to touch quickly on the double-edged sword that is exercise, and I just want to explain a certain nuance here that's important. So exercise is one of the best things that we can do for not only increasing the number of mitochondria that you have in your muscles, but then also because you increase tissue temperature, you also sweat. So it can actually give you some phase 2 detoxification as well. Both of these things are great for mitochondria. What I will say, though, is that understand we're talking about a hormetic stress. We're talking about something that is putting tension on your body. It is going to increase cortisol, etc. The other thing is, if you do have a suboptimal SOD2 pathway, I keep bringing up SOD2 because it's direct when it comes to mitochondrial clearance of endogenously created free radicals. So the more your heart rate elevates and the more you work out, we're getting these two benefits of sweating and increasing mitochondrial amount that you have, density, but we're also creating additional free radicals at the same time, which toxify the mitochondria. So if that pathway is suboptimal for you, we want to reap the reward, but we want to make sure that we're doubling down on other things that increase clearance. So I'll tell you one little strategy that I've been doing as an experiment. Every day after my workout, because I work out more than I should with a suboptimal SOD2 pathway, I've been doing hydrogen water and EAAs directly post-workout. The type of antioxidant pathway that it activates doesn't downregulate the inflammatory response of the exercise. So I get the benefit of the exercise, but it's specifically targeting the additional free radical buildup. And then EAA is a good idea for the amino acids for just building muscle. But just know, if you do have a suboptimal pathway there, you're going to want to introduce a little something extra to clear the free radicals so there is no downside to you doing additional exercise for healthy aging.
Wonderful. Thank you for that insight, because that's very helpful. And I want to say thank you for all of your information today that you have provided to our audience. Thank you, audience. Thank you for being here. We hope that you have gained some more information, that you are walking away with pearls of information, that you can go out and further do your own research, because we love having you here. We are here because of you. And if there are any topics that you would like us to dive into, contact us, let us know. You can put it, well, when this gets published, you can put it in the comments, because we are here for you. We want to provide you with the information that you want to learn. And I just want to say thank you again. Thank you to our incredible team in the background. We wouldn't, be supported or be able to do this without them. So have a beautiful night, everyone. Again, thank you, Justin. And
Thank you.
Have a beautiful day, everyone.